Right, good morning, Year 5-6. So we've got a maths lesson for Thursday, the 25th of February. Last maths lesson for this week. So Friday, tomorrow, you've got your Under the Sea topic day and learning activities to do. So last maths lesson as part of this unit for this week. So we'll start again with some arithmetic. So no more than 10 minutes. Try your best. Good luck. Pause the video now. Okay, number 1, 888 divided by 37 is 24. 2 and 1/5, add 4 and 1/10, got 6 and 3/10. You need to find the same denominator, then add them together. 65% of 320 is 208. Divide the 320 by 100, then multiply by 65. Fractions again, subtracting, we want to find the same denominator. We should end up with 5/8. 81% of 900, again, divide it by 100, then multiply by 81. We get 729. A third divided by 3. We're going to multiply the whole number by the, missed one. 8,468 times 68, 575,824. Now it's a third divided by 3. Multiply the whole number by the denominator, and we got 1/9. And then 2 1/2 take away a quarter. We've got 2 1/4. All right, we just want to do a quick recap of what we've been doing in terms of finding the area of rectangles, which we did just at the end of last term, and triangles, which we've been doing for the last few days. So pause the video and see if you can remember how to calculate these areas here. Okay, so the first one, we've got two rectangles. So the first two, we've got two rectangles. So we need to multiply the width by the height. So this one will be 8 times 1. We've got 8 meters squared. So remembering when we're doing the area, our units must be squared units. This one, we've got 90 multiplied by 40. So we've got 3,600 millimeters squared. And then with these two triangles, hopefully remembered from yesterday and the day before, that to calculate the area of the triangle, we need to calculate half the base times the perpendicular height. So we're going to say the base is 6, so half the base will be 3 times the perpendicular height, which would be 4. 3 times 4 is 12 centimeters squared. And then over here, we've got, again, 3 lengths. So we're going to say this length here of 14 centimeters is the base, multiplied by the perpendicular height, which is this 5 centimeters here. So half the base would be 7, multiplied by 5 would be 35 centimeters squared. Right, so today we are calculating the area of a, let's go back a step. We are calculating the area of a parallelogram. So what is a parallelogram? A parallelogram is a quadrilateral, and it has 2 pairs of parallel sides of equal length. So these sides are running parallel, and these 2 sides are running parallel, which means they are 2 sides which are running kind of alongside each other, but will never meet. So those 2 sides will run forever in the same distance apart, but will never come together and meet. And then they are of equal length. So what we can think of is actually a parallelogram is kind of like a slanted rectangle. And we can use that knowledge to try and help us find the area of a parallelogram, which is what we're trying to do today. So the first way we can think about trying to find the area of a parallelogram is how could we turn it into a shape which we can easily find the area of. Just like we did with the triangle, we turned the triangle into a rectangle, and then we halved it to be able to find the area of the triangle. We can kind of do the same with the parallelogram, because we can change it into a rectangle. Remember I said it's kind of like a squished rectangle, so we can easily change the parallelogram into a rectangle and then think about how much space that shape takes up. Because the problem with the parallelogram at the moment is that although I can count some whole squares, so in here I can count 1, 2, 3, 4, 5, 6, okay, so I know it's covering 6 squares at the moment, but I don't know how much of these squares it's taking up. I know that it's taking up some of these two squares. This is kind of over half, this is less than half, but I don't know exactly how much, and we're trying to calculate the exact area of these shapes. So what can I do? Well, I can manipulate the shape and turn it into a rectangle. So what I can do is I can cut off this right angled triangle here, effectively, and move it over to here. And what that will do is change the shape into a rectangle, but it will not change the actual amount of space that the shape is covering. It will still be covering the same amount of space because it fits perfectly. This bit of the shape here fits perfectly into this gap here. So I can cut off this right angled triangle, move it over, and if you look at this picture over here, I've moved it over to this gap, which was here, and it fits in perfectly. And what I can do now is calculate the area as if it was a rectangle. So I can measure the width, so 1, 2, 3, 4, and multiply it by the height, which is 2. And so the area would be 8 centimeters squared. So I can cut it and move it into this rectangle to make to be able to calculate the area of 8 centimeters squared. So let's have a look at another example. So what I can do with this one is I've got this right angle triangle here that I can cut and move into this gap here. So originally my parallelogram was this shape, and I'm cutting out this bit of the parallelogram here and slotting it into this gap here. And I know it will fit perfectly, and we can kind of look and see, because I've got 1 square, 2 squares, and a little bit here. And I've got, what space have I got over here? 1 square, 2 squares, and a little bit here. So because it is a parallelogram, we know that we're going to be able to move it around a little bit and get it to fit exactly in this gap here. And once I've done that, I've created myself another rectangle. So I've got a width of 3 centimeters here and a height of 3 centimeters. 3 centimeters times 3 centimeters will give us an area of 9 centimeters squared. Now, what you may have then realized is that we are using similar dimensions, similar measurements to what we were using when we were calculating the area of the triangle. We are looking at the base, and we are thinking about the perpendicular height. Because when we move, let's say we move this bit here, pretend that's a straight line again, we move this bit here over to fill in this gap here. What am I interested in? How would I calculate it? I would calculate it by doing the base times how high the rectangle is. So instead of, I can bypass the changing it into a rectangle bit and basically do the calculation as if it was a rectangle by doing 4 multiplied by the perpendicular height, because a rectangle would have to be perpendicular. The sides are perpendicular because they meet at a right angle. So I can cut this bit out, move it over to here. So we end up with a formula that we can use to calculate the area of the parallelogram. And it is very similar to the triangle. We are doing the base times the perpendicular height. But we're not halving it, because we don't want the area of a triangle. We're not then cutting the parallelogram in half to make it a triangle. We are purely calculating it as if it was a rectangle. We're changing it into a rectangle, then calculating it as such. But what we can do by using this formula is skip the whole step of cutting a bit out and moving it over. We can just calculate it straight away as if it was a rectangle, and we'll get the same answer. So with this one here, we do the base multiplied by the perpendicular height. So we've got 4 multiplied by 5 is 20 centimeters squared. So to find the area of a parallelogram, we do the base multiplied by the perpendicular height. So what do we need to make sure we can do? Well, we need to make sure we can identify the base and the perpendicular height. Well, as we said with the triangle, the base can be any side. Any side can be the base, but if you want to calculate the perpendicular height, that has to come from the base, and it has to come from the base to the top of the shape at a right angle. So on this example over here, which line is the base? It's going to be this side here is the base, and then we can see that this is coming from the base to the top of the shape at a right angle, because this is at an angle, a particular angle. This line is at a particular angle, and we've got a right angle here. So we can do 6 times 7 is 42. Here we've got 3 lengths. So which is the base, which is the perpendicular height? We've got the base here, which is this side, and then we've got the perpendicular height is this measurement here. This is not going in a straight line from the base. It is traveling at a different angle. And we need to remember that if we've got a side which is not going in a straight line at a right angle, that is going to be a different distance than if it was, because going not in a straight line is slower than if you're going in a direct straight line. So we need to know that perpendicular height. As if it was a rectangle, it would be going straight up at a right angle. So we need to do 3 times 5, which is 15 centimeters squared. So it's time for you to have a go at a couple of questions. So we've got some silver questions. You need to find the area of these parallelograms and think about what the mistake was made in this question here. So pause the video and have a go. Okay, let's have a look at the first ones. So we needed to find the area of this parallelogram. So we need to first identify the base. So I'm going to say that this length here is the base, and that is 3 centimeters. And the perpendicular height must come from the base, so it could be anywhere along here. I know that's the base, to the top of the shape at a right angle. So I'm going to go from here up to here, because that's how high this shape is from the base. So there's the height. And the height is 1, 2, 3 as well. So the height is 3, the base is 3, so we do 3 times 3 equals 9 centimeters squared. So we've got 9 centimeters squared over here. And then over this side, I'm going to say that this side here is the base, which is 2 centimeters, which means the perpendicular height must come from the base at a right angle to the top of the shape. So I'm going to say this is the perpendicular height. So it's 1, 2, 3, 4 centimeters. So then I do my calculation of the base times the height. So the base is 2, the height is 4, so I do 2 times 4, which is 8 centimeters squared. So Juan is finding the area of a parallelogram. What mistake has he made? Well, he has calculated 10 times 8 equals 80 centimeters squared. So he's calculated the base, which is multiplied by this 8 here. Now what we need to remember that although it goes from the base to the top of the shape, it is not going at a right angle. The perpendicular height must go at a right angle. If it's traveling at a different angle, it's going to be a longer length than the actual perpendicular height. So he should have done 10 times 6, which would have given him 60 centimeters squared. So what mistake has he made? He hasn't used the perpendicular height. What is the correct answer? 60 centimeters squared. All right, looking at these ones now. So pause the video again and try and find the area or missing lengths of these shapes. Okay, the first one, so we follow our calculation. Where's the base? Here. Where's the perpendicular height? Here. 4 times 5 is 20. Down here, the base is 2, the perpendicular height is 5, so we do 2 times 5, which is 10. Here we've got the base here, which is 5, multiplied by the perpendicular height, which is 6, so 5 times 6 is 30. And then here we've got 3 lines this time, so we need to make sure we do the right ones. So we've got the base of 6, the perpendicular height of 3, which is 18 meters squared. With this one, we needed to find the missing length here. So we're trying to find the base. So something, the base, multiplied by 5, because 5 is the perpendicular height, equals 15 centimeters squared. So what times 5 equals 15? 3 times 5 equals 15. So here we should have 3. All right, this time we've got some slightly different units of measurement to try and confuse us this time. So the area, we've been given an area of 12 meters squared, but the measurements are in centimeters. So we could change these measurements into meters to make sure that we're able to calculate it. So we could divide the 400 by 100 to make it turn it into meters. So we know that's going to be 4 meters multiplied by how many meters makes 12 meters. 4 times 3 equals 12. So we're going to say that that is 3 meters or 300 centimeters we could fit into there. Final questions, platinum this time, so pause the video again and have a go. Okay, so the first one, Teddy has drawn a parallelogram. The area is greater than 44 meters squared, but less than 48 meters squared. What could the base length and the perpendicular height of Teddy's parallelogram be? So we've got different possible answers. So it could have been 9 meters by 5, because 9 times 5 is 48, which is between 44 and 48. 6.5 by 7, which will give us 45.5, or 11 by 4.2, which gives us 46.2. As long as you've got 2 numbers you multiply together, which then give an answer between, it must be more than 44 and less than 48. So you might have had different answers to this one. Okay, this one down here, Dexter thinks the area of the parallelogram is 84 centimeters squared. What mistake has Dexter made? What is the correct answer? So he thinks it's 84. So did he maybe do 14 times 6? Dexter has multiplied 14 by 6 when he should have multiplied by 4, because 4 is the perpendicular height of the parallelogram. So the correct answer is 56 centimeters squared. So he didn't calculate by the perpendicular height. He calculated by this length here. Over to the final one. Dora and Eva are creating a mosaic. They are filling a sheet of paper this size, so 19 by 15 centimeters. Dora's using tiles that are rectangle. Eva's tiles are parallelograms. Dora thinks that she will use fewer tiles than Eva to fill the page because her tiles are bigger. Do you agree? Explain your answer. So hopefully you thought back to what we were saying at the start and how we could cut out the parallelograms to make them the same size as a rectangle. So Dora is wrong, because both hers and Eva's tiles have the same area. So because this tile is 5 by the perpendicular height of 3, this tile is also 5 by 3. So the area of both of these, even though this is a parallelogram and this is a rectangle, they both have an area of 15 centimeters squared. So they have the same area, and so the same number of tiles will be needed to complete the mosaic. The area of the paper is 285 centimeters squared, and the area of each tile is 15 centimeters squared. So 19 tiles are needed to complete the pattern. If it's in this particular shape, then maybe the tile cutter is needed to try and cut the tiles into the right shape. But either way, it's going to use the same number of tiles, just might need fitting in slightly. All right, so that brings us to the end of finding the area of parallelograms today. So well done, and I hope you really enjoy your topic day tomorrow and have fun doing some of the activities. And I'll see you next week.